Okay, so we were finishing off section 12.1 last time, solving systems of linear equations in three variables, three or more variables. And so the last problem we did was problem number 26 on page 513. So let's say problem number 29. Let's call this R1. 2x minus y plus 6z equals negative 5. R2, x plus 5y minus z equals 7. So this is what's called an undetermined system of linear equations because there are less equations. So there are fewer equations than variables. So in this case, I have two equations, but three variables. So that's underdetermined. If I happen to have it in the other way, so an overdetermined system, is one where there are more equations than variables. And so, say if we have, I don't know, 15 equations, but only three variables. So usually with overdetermined systems, we usually have lots of solutions. Well, I'm sorry, with underdetermined systems, we usually have lots of so for undetermined systems, we have many solutions. Usually, not always. And for overdetermined systems, usually we have few or no solutions. Of course, this is not always true, but more or less true. Okay, so in this case, we have an undetermined system. So we would expect that we're going to have an infinite number of solutions. And let's see if that's what happens in this particular case. So I guess let me try to eliminate y. So I'll use the first and second equation to eliminate y. I guess I'll multiply the first equation by 5. 10x minus 5y plus 30z equals negative 25. And then I'm going to add that to the second equation. Oh, okay. Plus R2 x plus 5y minus z equals 7. Okay, so let's add these. And so I get 11x. The 5y's cancel. Plus 29z equals negative 18. Okay. And I don't know, maybe I'll call that S1. But I've used my two equations and there's no equations left, so that's really about it. So the solution is going to look something like this. And so there are two variables. I can really only solve for one variable in terms of the other. Let's x equal t, and then I'll solve for t. Actually, let x equal 29t. Okay. And so, if I do that, and the reason that I'm picking 29t is because I noticed that there's a 29 in front of the z, and that'll just make the calculations, well, it'll just make the answer look a little bit nicer, maybe have fewer fractions. And so if I plug this into S1, I get 11x 29t plus 29z equals negative 18. Okay. That's actually not going to help it that much because when I put it over there, I'm still going to have a fraction. Well, okay. Yeah, I guess it won't help it that much in this case. So let me just let x equal t, and unfortunately, no matter what I do, I guess, I'm going to have a fraction somehow involved in this. And so 11t plus 29z equals negative 18. Subtract 11t from, and so solve my equation for z. Subtract 11t from both sides of my equation. So I get 29z equals negative 11t minus 18. Divide both sides of my equation by 29. And so I get z equals a negative 11t minus 18 over 29. So I figured out x, I figured out z, and now I want to figure out y, so I can just plug into, let's say, the first equation, r1. Okay, so let's do that. So I have 2x minus y plus 6z equals negative 5. Okay, so let's simplify that. So that's 2t minus y plus a negative 66t minus, let's multiply 6 times 18. 108 over 29 equals negative 5. So let me multiply both sides of this equation. By 29 to get rid of the denominator. And so I get 58t minus 29y. The 29's cancel, so minus 66t minus 108 is equal to 29 times 5, negative 145. Combine like terms. So I have 58, I have 58 minus 66, 58t minus 66t, negative 8t, minus 29y minus 108 equals negative 145. Let me add 108 to both sides of my equation. And let me add 8t to both sides of my equation. So I get negative 29t is equal to a negative 37 plus 8t. Let me divide both sides of my equation by negative 29. And well, the negatives are going to cancel. So I get t. Oops. How did I get a t? So I get y equals, changing all the signs, 37 minus 8t over 29. Therefore, my solution is x, which is t. Y, which is 37 minus 8t over 29. And z, which is negative 11t minus 18 over 29. Okay, and so this is my one parameter family of solutions. So I notice I have an infinite number of solutions, and I can write this as a one parameter family of solutions. Okay. And so this is a line in the plane. So these two planes intersect along a line. Let me do problem number 32. Two x minus y plus 2z plus w equals 1. R2 x plus y plus z minus w equals negative 1. R3 3x plus 2y minus z plus 2w equals 6. R4 x minus 3y plus z minus 3w equals negative 3. Okay? So I guess first thing is actually just looking sort of below. This is called a non-homogeneous system. And this is because the right-hand side is a whole bunch of objects that are not all zero. So the terms that are not constant, not variable pi, so the constants on the right side are not all zero. Okay. If they were all zero, then we would call this a homogeneous system. So in a homogeneous system, all the constants are zero. Okay. So I guess the first thing to do is to figure out what variable I want to eliminate. So x, y, z, or w. I guess in this case, what I'll eliminate is y. I'll eliminate y. Yeah, let's eliminate y. You could eliminate w too. Almost all of them you could eliminate. I guess I'll eliminate y. Okay, so to eliminate y, I guess the first thing I'll do is I'll just add the first and second equations. So R1 plus R2. R1, 2x minus y plus 2z plus w equals 1. R2, x plus y plus z minus w equals negative 1. So let's add these. So I get 3x, y's cancel, plus 3z, w's cancel, equals 0. Let me divide everything by 3. And so I get x plus z equals 0. I'll call that S1. Okay, I've got to, I have to keep eliminating all of my y's. Let me do that. So if I look here, I can add the second, third, and fourth equations, and that will eliminate all of my y's. So let me do that. So let's just do R2 plus R3 plus R4. Okay, and so X plus Y plus Z minus W equals -1, 3X, 3X plus 2Y minus Z plus 2W equals 6. X minus 3Y plus Z minus 3W equals -3. So let's add. So that becomes 1x plus 3x plus x is 5x. Y plus 2y is 3y minus 3y is 0. Z minus Z cancels, plus Z. W minus 2w is 1w minus 3w is minus 2w equals -1 plus 6 is 5 minus 3 is 2. So let's call that S2. Okay. And lastly, I have to find one more equation where I have eliminated my y. So let's do, if I look up here, I can multiply the first equation by 2, add it to the third equation. That'll eliminate y. And so let's take 2r1 plus r3. And so I get 4x minus 2y plus 4z plus 2w equals 2. Let's do R3, which is 3x plus 2y minus z plus 2w equals 6. Let's add these. Let me just check to be sure I wrote everything correctly. So that's 4x minus 2y plus 4z plus 2w equals 2. Correct. Okay. And so let's add these together. And so I get 7x. The y's cancel. Plus 3z plus 4w equals 8. So let's call that R3. Okay, so now I have 3 equations, 3 unknowns. So I have S1, x plus z equals 0. I have S2, 5x plus z minus 2w equals 0. And I have S3, 7x plus 3z plus 4w equals 8. Let me eliminate w, since there's no w in the S1. So I can do that. So let's eliminate w. And so let us multiply S2 by 2. 10x plus 2z minus 4w equals 4. And let's add that to S3. Seven x plus 3z plus 4w equals 8. And so I get, let's call it T1, 17x plus 5z, the w's cancel, equals 12. I also had T2, which is really my, I think it was called S1. And so S1, which was the x plus z equals w. And so, yep, s plus z is equal to 0. Okay, so I have two equations, two unknowns. Let's eliminate z. And so let's do T1, 17x plus 5z equals 12. Multiply the second equation by -5. So -5x minus 5z equals 0. Add 12x is equal to 12. Okay, so let me divide both sides of my equation by 12. So that says that x is equal to 1. Let me use T2. And so that says that x plus z equals 0. Subtract 1 from both sides of my equation. So z equal -1. Okay. So I figured out x and z. Let's x and z. And let's figure out w. xz I guess S3 is, none of them is tremendously easy, but it's either S2 or S3, but yeah, maybe S2. So 5x plus z. S2. 5x plus z. 5x plus z. 5x plus z minus 2w equals 2. And let me just check once more. 5x plus z, 5x plus z minus 2w equals 2. Okay, correct. And so 5 minus 1 minus 2w is 2. So 4 minus 2w is 2. Subtract 4 from both sides of your equation. Negative 2w equals -2. Divide by -2. W equals 1. So I have x, z, w. I need y. Let's go for y. Let's do R2. Okay, so let's do R2. So I have x, which is 1. Oh, we're doing R. So I have x plus y plus z minus w equals -1. And so the ones cancel, so I get y minus 1 equals -1. Add 1 to both sides of the equation. And so I have y is equal to 0. And so my solution, maybe I should write it all together. And so my solution is x is 1. Yep. Y is 0. Z is -1. And w is 1. And that is your solution. Let me do any questions about that. Okay. Let me do problem 46. So in this case, I'm going to be looking at these homogeneous equations. And so in exercises 34 through 50, solve the homogeneous system of equations. Okay, so let's do that. So let me do, let's say, problem number 46, R1. 2x minus 3y minus z equals 0. R2, x plus 3y minus 2z equals 0. R3, x minus 3y equals 0. Okay, so let me try to solve this system. So let's eliminate z, since R3 does not contain z, so I'll try to eliminate z. Right. So if you look at the actual equation, this system, the third equation actually doesn't include a z, and so it could just be that the third equation doesn't have a z value, and in that case, it'll actually make the solution. It'll make you'll be able to find the solution easier, just because you're already sort of there, because already one of the variables have been eliminated. And so that makes our life a little bit easier. So why don't I do negative 2r1, negative 4x plus 6y plus 2z equals 0, and add that to r2. X plus 3y minus 2z equals 0. So if I do that, I get negative 3x plus 9y plus, well, the z's cancel, equals 0. Let me divide by negative 3. So I get x minus 3y equals 0. And so let's call that S1. But if I notice, if I take S1, so I've eliminated all of my z's. Now I can eliminate, well, let's say, x. And so I'll take S1 and I'll take R3 multiply R3 by negative 1. If I add these together, I get 0 equals 0, which means there's an infinite number of solutions. And so what that meant is, and of course if you just looked, notice that S1 is the same as R3. So it means really we only have two equations and two unknowns. And so that means that this is an undetermined system of equations. And so why don't I let y equal t. And so I can just sort of note that really this third equation here is really the same as some combination of the above two equations. So I really didn't even need that third equation. And so let's look at S1. So I get x minus 3y equals 0. And so add 3t to both sides of your equation. So it says x is equal to 3t. Now I can plug into really almost any equation here. Well, R1 or R2. Maybe I'll plug into R2. So I have x plus 3y minus 2z equals 0. And so I get 3t plus 3t minus 2z is 0. So I get 6t minus 2z is 0. Let me subtract 6t from both sides of my equation. So negative 2z equals negative 6t. Divide by negative 2. So z equals 3t. So therefore, my solution can be written as x, which is 3t, y, which is t, z, which is 3t. And this is true for all t. Actually, I should have written that above for the other one. For the underdetermined system. Stop. I should write that right there. And this is for all t. Okay. And so this is, I've written my solution as a one parameter family of solutions. The parameter being t. So this is a one parameter